guys, this is Kair. We are using smart traffic management system using cameras and microphones to improve the efficiency of the intersections.
So our objective is to increase the efficiency of traffic lights and traffic flow. This will be done by using a webcam to count how many people are approaching the intersection from each direction, and then using that information to change the lights to prioritize the busier lane. We will also use a microphone to detect the sounds of emergency vehicles and change the lights so that they have the green light.
We are using 2 cameras and 2 microphones as a sensor for our measurement system. So first let's get into the cameras. All the cameras work on the same principle. They have an image sensor that captures the stream of moving images and converts them into a digital signal. Most widely used image sensor is called complementary metal oxide semiconductors or CMOS. In a CMOS sensor, there are millions of pixels, and each pixel has a photodiode and a transistors. Photodiode captures the light and converts it into electrical energy by charging the electrons. Transistors function as a resetting and reactivating that pixel, amplification, and a charge conversion. Now let's get into microphones. The most widely used microphones is a moving coil type microphone, which uses electromagnetic induction to convert the sound waves into electrical signal. It has a tiny coil of thin wire suspended within a magnetic field. As sound waves hit the flexible diaphragm, the diaphragm moves back and forth in response to a sound pressure acting upon it, causing the attached coil of wire to move within a magnetic field and induce a proportional voltage. This voltage is defined by Faraday's electromagnetic induction laws. Since the coil is a low impedance and the output voltage is very small, some form of pre-amplification of the signal is required.
The webcams will play the role of determining the path of the car and the quantity per direction. The microphones will differentiate between the two types of vehicles by taking the frequency it outputs. So from there on, signal conditioning will be performed on both the webcams and the microphones. For the webcam, image processing will be used to count the vehicles by the color, and for the microphone, sound filtering will be used to take certain frequencies to distinguish whether the vehicle is a normal car or emergency. Additionally, an amplifier may be used in the case where the signals from the microphone are not strong enough. And finally, the data collected will be run through a DAQ device, more specifically the Quanser Q8 USB, to convert the data. And in the last step, the reading stage, the LabVIEW program will quantify the data collected, and based on the logic of the program, will change the traffic lights accordingly to increase traffic efficiency.
Smart traffic control systems are embedded in the infrastructure of many cities today. They are used for detecting congestion, synchronizing activity between traffic lights, updating traffic light timing, updating and informing drivers of ideal speeds, and prioritizing transportation flow. A good example of an existing system is SawTruck by Robotics Institute at Carnegie Mellon University. This is an image of how the system works. Advanced sensing infrastructure is used to relay information in real time and optimize traffic control. Many cities use big data and the Internet of Things to transfer information to a central system for analysis. Examples of IoT devices used include sensors, vehicle-mounted information systems, and even private mobile phones. In conclusion, smart traffic systems are used in many cities today and can be incredibly essential, especially in situations of high alert, national emergency, or mass hysteria.